From the moment our ancestors first gazed up at the night sky, a profound fascination with the stars ignited within human hearts. Those pinpricks of light, shimmering against the vast darkness, have always beckoned us, inviting curiosity about what lies beyond our earthly realm. The cosmic dream is not merely a whimsical fantasy, it is the deep-seated desire to explore, to understand, and to transcend the limitations of our home planet. This collective yearning has shaped our stories, driven scientific inquiry, and inspired generations to reach for the impossible. As we stand on the precipice of a new era, the allure of the cosmos is more potent than ever. We are curious beings, always looking for answers to questions that seem to stretch into infinity. What is out there? Are we alone in the universe? Can we venture beyond the confines of our atmosphere, traverse the vastness of space, and perhaps even colonize other worlds? These questions resonate deeply within us, speaking to our very nature as explorers. They drive our ambitions and fuel our imagination, pushing us toward the stars. In ancient times, the night sky was a tapestry woven with myths and legends. Those distant celestial bodies were seen as deities, guiding forces, and signs of destiny. As we evolved, so did our understanding of the universe. From the heliocentric model proposed by Copernicus to the revolutionary insights of Galileo, each leap in knowledge propelled us further into the cosmic narrative. The dream of reaching the stars became intertwined with our identity, a symbol of humanity's relentless pursuit of knowledge. Today, we find ourselves at a remarkable intersection of technology and aspiration. The advancements in our understanding of physics, coupled with extraordinary innovations in engineering, are slowly transforming the dream of space travel into a tangible reality. The once fantastical visions of science fiction are now within our grasp, reshaping our view of what humanity can achieve. The cosmos is no longer just a distant dream, it is becoming our next frontier. Yet, this journey is not purely about exploration, it is also an endeavor steeped in reflection. As we look to the stars, we are compelled to confront the fragility of our own planet. The challenges we face, climate change, resource depletion, and societal strife underscore the importance of our cosmic aspirations. The dream of colonizing other worlds is not just about escaping our problems, it's about finding new homes and new opportunities to thrive as a species. It encourages us to innovate, to create sustainable technologies, and to seek harmony with our environment. Imagination fuels our forward momentum. Just consider the breathtaking possibilities. Imagine spacecraft powered by the very principles of quantum mechanics, allowing us to traverse distances that once took lifetimes in mere months. Picture colonies on Mars where humans forge new lives, employing cutting-edge technologies to create sustainable ecosystems. Envision fleets of autonomous drones exploring the ice-covered moons of Jupiter, seeking out signs of extraterrestrial life. These scenarios are not mere daydreams, they are the foundations of our aspirations, built on the scaffolding of scientific progress. As we embark on this cosmic journey, we must also recognize the responsibility that comes with it. Colonizing other planets raises profound ethical questions. What does it mean to inhabit a new world? How do we ensure that we do not repeat the mistakes of the past? Our cosmic dream must be guided by principles of stewardship and respect for the unknown. We are not just explorers, we are caretakers of the universe, tasked with treating it with reverence and care. The dream of transcending our earthly bounds also calls for collaboration across cultures and borders. The cosmos does not belong to any single nation, it is a shared heritage for all of humanity. Together, we have the potential to create a united front in our quest for knowledge and understanding. International partnerships in space exploration can amplify our efforts, allowing us to pool resources, share insights, and foster a sense of global unity. By working together, we can realize the cosmic dream not as individual nations, but as a unified species reaching for the stars. As we look ahead, the allure of the universe shines brighter than ever. With each passing day, our understanding of the cosmos expands, revealing mysteries that inspire awe and wonder. The technology we develop pushes the boundaries of what we thought possible, igniting a new spirit of exploration. Humanity's enduring fascination with the stars is not just a dream, it's a call to action, a reminder of our potential, and an invitation to embrace the unknown. The cosmic dream is alive within us all, urging us to keep reaching higher and dreaming bigger. We are on the verge of a transformation, a moment in history when our aspirations align with the capabilities of modern science. The road ahead is filled with challenges, but it is also brimming with possibilities. As we embark on this extraordinary journey, we must remember that the stars are not just destinations to reach, they are symbols of hope, guiding us toward a future where humanity thrives not just on Earth, but throughout the cosmos. In this pursuit, we find purpose, connection, and the promise of a brighter tomorrow among the stars. As we delve deeper into the vastness of our cosmic ambitions, we must turn our gaze inward, to the very fabric of reality itself. At the heart of our universe lies a domain of astonishing complexity and beauty, the quantum realm. This is a universe where the rules we take for granted dissolve into an intricate dance of probabilities, where particles behave in ways that defy our classical intuition, and where the act of observation itself plays a pivotal role in shaping existence. Quantum mechanics reveals a world that operates on principles so different from our everyday experiences that they can feel almost surreal. In this realm, particles are not merely tiny, solid objects, instead, they exist in a state of uncertainty. Until they are measured, they can be found in multiple states at once, a phenomenon known as superposition. Imagine a tiny particle existing simultaneously in countless locations, its future determined only when we finally look at it. This fundamental unpredictability challenges everything we thought we knew about the nature of reality and opens up profound implications for our understanding of the universe. One of the most astonishing aspects of quantum mechanics is entanglement, a phenomenon that links particles in such a way that the state of one instantaneously influences the state of another, no matter how far apart they are. It's as if these particles share a connection that transcends space and time, allowing them to communicate instantaneously. This strange bond defies the limitations of classical physics, suggesting a deeper interconnectedness within the universe. The implications of entanglement extend beyond the theoretical, they hold the potential to revolutionize technologies, including communication systems that are faster and more secure than anything we currently possess. As we explore the quantum realm, we venture into the very essence of what it means to be human. The principles of quantum mechanics challenge us to rethink our perceptions of reality and to embrace a world where certainty is an illusion. When we apply these concepts to the exploration of space and the journey to the stars, we begin to glimpse a future where our understanding of the cosmos expands exponentially. Imagine harnessing the power of quantum mechanics to develop technologies that allow us to communicate across vast distances or to process information at unimaginable speeds. At the forefront of this quantum revolution is quantum computing, a pioneering field that promises to redefine our approach to problem solving. Unlike classical computers, which rely on bits as the smallest unit of information, quantum computers utilize qubits, which can exist in superposition. This capability enables them to perform complex calculations at speeds that far surpass those of traditional machines. In a universe filled with unsolved mysteries, from the nature of dark matter to the mechanics of black holes, quantum computing offers a beacon of hope. It can help us simulate the conditions of distant planets, analyze cosmic data, and potentially unlock secrets that have eluded humanity for centuries. Yet, the quantum realm does not solely belong to the realm of technology. It invites us to contemplate our place in the universe. It encourages a philosophical reflection on the nature of existence and the interconnectedness of all things. As we contemplate the fabric of spacetime, we begin to appreciate that our journey to the stars is not just a pursuit of exploration but an invitation to understand the very building blocks of the cosmos. The quest for knowledge becomes intertwined with a quest for purpose. As we harness the principles of quantum mechanics to propel our journey through space, we face the profound responsibility that accompanies such power. The ethical implications of manipulating the fundamental forces of nature weigh heavily on our shoulders. We must navigate the delicate balance between exploration and exploitation, ensuring that our advancements serve the greater good. How do we wield the transformative potential of quantum technology without losing sight of our moral compass? This is a question that will shape our future as we venture into the unknown. In this age of discovery, we are not alone. The pursuit of quantum knowledge transcends borders, inviting collaboration among scientists, engineers, and dreamers from around the globe. As we harness our collective expertise to push the boundaries of what is possible, we foster a sense of unity in our shared quest for understanding. This collaboration will be essential as we look to the stars, transforming the insights gained from the quantum realm into practical applications that can support our explorations. As we stand on the cusp of what was once deemed impossible, we must remember that the quantum realm is not just a distant abstraction, it is the very foundation of our universe. It encourages us to embrace uncertainty, to seek connections where none seem to exist, and to explore the depths of reality with awe and humility. Every breakthrough in quantum understanding serves as a reminder of our infinite potential and the boundless paths that lie ahead. Ultimately, the quantum realm beckons us towards a future filled with wonder and possibility. As we continue our journey toward the stars, we carry with us the knowledge that the universe is not merely a vast expanse of empty space, but a dynamic tapestry woven from the very essence of existence. This understanding will guide us as we transform our cosmic dreams into reality, ensuring that our journey is not just about reaching new worlds, but about rediscovering our profound connection to the universe itself. As we stand on the threshold of a new era in space exploration, it is essential to reflect on the remarkable journey that has brought us here. The evolution of space travel technologies is not just a tale of rockets and satellites, it is a testament to human ingenuity, determination, and the unyielding desire to explore the unknown. From the first tentative steps beyond our atmosphere to the ambitious plans for interstellar travel, each leap has paved the way for our cosmic ambitions, propelling us toward a future where the stars may no longer be out of reach. In the early days, space exploration was defined by the monumental achievements of the mid-20th century. The launch of Sputnik in 1957 marked humanity's inaugural step into the cosmos, igniting a race not just for technological supremacy but for a deeper understanding of our place in the universe. As we sent astronauts beyond the Earth's atmosphere, we unlocked the mysteries of microgravity and the effects of space on the human body. The subsequent Apollo missions ignited the imagination of generations, bringing the moon within our grasp and proving that with courage and innovation, no destination is impossible. Yet, the voyage to the stars is not merely about physical travel, it is also about technological evolution. The advancements in materials science have led to stronger and lighter materials, allowing us to construct spacecraft capable of withstanding the harshness of space. Innovations such as carbon composites and advanced alloys have redefined the limits of what we can build, enabling spacecraft that can travel farther and endure longer in the unforgiving environment of space. Each new generation of spacecraft incorporates lessons learned from previous missions, enhancing safety and efficiency while expanding our horizons. Moreover, the rocket technology that propelled us into the cosmos has undergone a transformation of its own. From the powerful Saturn V that took humans to the moon to the reusable Falcon 9, the evolution of launch systems is a prime example of how innovation can redefine the landscape of space exploration. The introduction of reusable rockets has drastically reduced the cost of sending payloads into orbit, democratizing access to space and opening the door for a new wave of exploration. This shift not only changes the economics of travel but also enables more frequent and varied missions, laying the groundwork for future endeavors that once seemed like distant dreams. As we venture further into the solar system, our aspirations have grown even bolder. The establishment of permanent human presence on the Moon and Mars is no longer relegated to science fiction. With projects like NASA's Artemis program, we are on the cusp of building sustainable habitats on the Moon, which will serve as stepping stones for future missions to Mars and beyond. These ambitious plans hinge on the integration of cutting-edge technologies, from advanced life support systems to in situ resource utilization, which will allow us to thrive in environments that are foreign to us. The advancement of propulsion systems is also crucial in this new era of exploration. Traditional chemical rockets, while effective, limit the speed and range of our missions. However, the advent of innovative propulsion technologies such as ion drives and solar sails is reshaping our approach. These systems offer the potential for faster travel times and greater efficiency, making distant destinations like the outer planets more accessible than ever before. Imagine a spacecraft powered by the continuous light of the sun, gliding silently through the void, its sails unfurled to harness the very energy of the cosmos. But it is not just propulsion that will define our journey. An impressive array of technologies awaits us as we prepare for deeper exploration. The development of autonomous systems and robotics will play a pivotal role in our ability to explore hostile environments. Robots can venture where humans cannot, conducting experiments, collecting samples, and even building infrastructure on distant worlds. The Mars rovers have already shown us the value of robotic exploration, providing invaluable data that informs our understanding of the Martian landscape and influencing our strategies for future human missions. As we look to the stars, the idea of energy becomes paramount. Harnessing energy from celestial bodies, such as solar power collected from orbit or even nuclear fusion, could provide the sustainable energy sources we need for long-duration missions. This shift in thinking about energy will not only support our technological endeavors but also lay the groundwork for future colonization efforts, where self-sustaining habitats will be essential for survival on other planets. The experience we gain from exploring our solar system will serve as a precursor to interstellar travel. Although the vast distances between stars seem insurmountable with current technology, the groundwork laid by our exploration of nearby worlds will enlighten our understanding of the challenges we face. Each mission, each experiment, spins a thread in the fabric of knowledge that is essential for tackling the cosmic distances that lie ahead. In this new era of space exploration, international collaboration will be essential. Countries around the globe are joining forces, pooling resources and knowledge to tackle the shared challenges of space. This spirit of cooperation not only enhances our technological capabilities but also fosters a sense of unity in the pursuit of a common goal. Our journey to the stars is one that transcends borders, inviting all of humanity to partake in the wonder of discovery. As we evolve, propelled by the insatiable curiosity that defines us, we find ourselves standing on the brink of extraordinary possibilities. The tapestry of humanity's cosmic journey is being woven before our eyes, thread by thread, innovation by innovation. Each technological advancement serves as a beacon, illuminating the path forward as we strive not just to reach new worlds but to understand the very nature of our existence within this magnificent universe. With every leap into the unknown, we redefine what it means to be explorers, forging a legacy that will echo through the ages. As we stand on the precipice of this cosmic journey, one remarkable technology promises to redefine the very fabric of our problem-solving capabilities: quantum computing. This revolutionary approach to computation harnesses the peculiar and often mind-bending principles of quantum mechanics, enabling us to process information in ways that classical computers can only dream of. Imagine a machine that operates not just on the binary logic of zeros and ones but on the complex interplay of quantum bits, or qubits, existing in multiple states simultaneously. This is the realm where quantum superposition and entanglement transform our understanding of computation and problem solving. The power of quantum computing lies in its potential to tackle problems that are currently insurmountable. Take, for instance, the challenge of navigating the vastness of space. Interstellar travel requires calculations that consider countless variables, from fuel efficiency to orbital mechanics, and even the unpredictable gravitational influences of celestial bodies. Classical computers, while powerful, struggle under the weight of such complexity, often taking years to solve equations that quantum computers could potentially unravel in a matter of seconds. This leap in computational power could mean the difference between a successful mission to distant worlds and a missed opportunity, allowing us to chart courses through the cosmos with unprecedented precision. As we delve deeper into the quantum realm, we begin to understand how this technology can revolutionize spacecraft design and mission planning. Quantum computing could allow engineers to simulate and optimize spacecraft performance under various conditions, leading to innovative designs that maximize efficiency and safety. Imagine spacecraft that not only harness advanced materials but are also designed with the computational foresight provided by quantum algorithms, enabling them to adapt in real time to the challenges of interstellar travel. Moreover, quantum computing offers exciting possibilities for communication and data analysis. In a universe where distances can span light years, sending and receiving information becomes a daunting task. Quantum communication, bolstered by quantum entanglement, promises to create ultra-secure channels for transmitting data across vast distances, effectively creating a cosmic internet. This would not only enhance our ability to maintain contact with distant missions but could also facilitate real-time data sharing, allowing scientists on Earth to collaborate with explorers in far-flung corners of the cosmos. Imagine being able to transmit vast amounts of scientific data gathered from the surfaces of exoplanets back to Earth in seconds, or sharing real-time updates from the edge of a black hole. Quantum computing doesn't merely enhance our current capabilities, it opens up new avenues of exploration and understanding, providing insights into phenomena previously thought beyond our grasp. But the potential of quantum computing extends far beyond navigation and communication.
It also plays a crucial role in solving complex mathematical problems essential to understanding the universe.
Many of the mysteries of the cosmos, from the nature of dark matter to the behavior of black holes, are intricately tied to equations that require immense computational resources to solve.
With quantum computing, we stand on the brink of a new era in theoretical physics, where simulations and models can lead to breakthroughs that might unravel the secrets of the universe or even help us devise strategies for terraforming other planets.
As we consider the ethical implications of space exploration, the advent of quantum computing presents a myriad of questions.
How do we ensure that this powerful technology is used responsibly? As we venture into the cosmos, the consequences of our actions will ripple through the fabric of space and time.
Understanding the ethical dimensions of our progress, especially when it comes to the power of quantum computing, is essential. We must establish frameworks that guide us in making decisions that honor both our responsibility to our home planet and our aspirations among the stars. In addition to ethical considerations, the collaboration between human intelligence and quantum computing raises fascinating possibilities. As artificial intelligence continues to evolve, quantum computing could enhance the capabilities of AI systems, enabling them to solve problems and analyze data at speeds and complexities that were once unimaginable.
Imagine AI systems that can think ahead, predict outcomes based on vast data sets, and even understand the nuanced dynamics of alien ecosystems.
This partnership could lead to more efficient exploration missions, with AI systems guiding us through the unknown, making decisions that reflect a deep understanding of both human values and the realities of the cosmos. As we look to the future, the interplay between quantum computing and our quest for the stars paints a picture of unlimited potential. The very notion of interstellar travel, which once seemed like a far-fetched dream, is being brought closer to reality through the power of quantum technology. The intricate calculations required for such journeys, the simulations that could predict the habitable conditions on distant planets, and the instantaneous communication across the vastness of space all hinge on our ability to harness this quantum leap. In this grand tapestry of cosmic exploration, quantum computing stands as a pivotal thread, weaving together the dreams of humanity and the tangible possibilities of tomorrow. With each advance, we inch closer to not just understanding our universe but becoming an integral part of its story. As we embrace this technology, we are not merely enhancing our capabilities, we are redefining what it means to be explorers, pioneers of the cosmos, ready to embark on journeys that will forever alter our understanding of existence itself. The stars await, and with the power of quantum computing at our fingertips, the next chapter in our cosmic odyssey is poised to unfold. As we stand on the brink of this new era, we must turn our gaze to the extraordinary phenomenon of quantum entanglement. This is no mere curiosity of the quantum realm, it is a powerful tool that has the potential to reshape our very notion of communication across the vast expanses of space. At its core, quantum entanglement reveals a deep interconnectedness between particles, a mysterious bond that transcends the limitations of distance and time. Imagine two particles, born from a single event, separated by light years yet still intimately linked. When one particle is manipulated, the other responds instantaneously, no matter how far apart they are. This defies our classical understanding of physics, suggesting that information can be shared in ways we have yet to fully comprehend.
The implications are staggering.
If we can harness this phenomenon, we could revolutionize our ability to communicate with spacecraft journeying far beyond the reach of traditional signals, which diminish in strength over vast distances. In the void of space, where time and distance conspire to create communication delays, quantum entanglement offers a glimmer of hope. Consider a mission to Mars, which may take several minutes for a signal to travel back and forth. Now, envision a network of entangled particles bridging the gap between Earth and those deep space explorers, allowing for instantaneous communication.
Imagine the possibilities for real-time data sharing, guidance, and collaboration between distant spacecraft and their terrestrial counterparts.
This concept, often described in the realm of quantum theory, could soon transition from theoretical musings to practical applications, transforming how we connect with missions that are not just a few kilometers away, but millions. As we delve deeper into the intricacies of quantum mechanics, we begin to grasp the nuances of this entanglement. It's not merely about faster communication, it's a paradigm shift in our understanding of information transfer. The quantum world operates under principles that challenge our conventional interpretations of reality. This interconnectedness hints at a universe woven with threads of collaboration, where the separation of space is merely an illusion. This could lead to the development of a quantum internet, a network that allows for secure, instantaneous communication, fundamentally changing our approach to data transfer and leading to breakthroughs in fields from cryptography to satellite technology. Yet, the promise of quantum entanglement goes beyond communication. It hints at a future where we can share resources and information across vast distances with minimal delay. As we contemplate the establishment of colonies on distant planets or moons, having immediate access to data could be crucial for survival and development. From environmental monitoring on Mars to the maintenance of life support systems, the applications of instantaneous communication could be the difference between success and failure in extraterrestrial endeavors. In addition to revolutionizing communication, quantum entanglement could play a vital role in enhancing our navigational capabilities. With the vastness of space presenting unique challenges, the precision of our navigation systems becomes paramount. Quantum sensors, leveraging entangled particles, could enable us to measure gravitational fields with unprecedented accuracy, allowing for the mapping of cosmic phenomena that influence our path. This could lead to safer and more efficient travel through the ever-expanding universe. However, the journey to fully realizing the potential of entanglement is not without its hurdles. The very nature of quantum mechanics introduces complexities in control and scalability. Scientists and engineers are tirelessly working to create stable entangled states that can be reliably maintained and manipulated, paving the way for practical applications. As we make strides in quantum technology, we are also prompted to ponder the ethical implications of such power. With the ability to communicate instantaneously across the cosmos, questions arise about the control and security of such technologies. Who will have access to this quantum communication network? How do we protect it from misuse? The quest to harness quantum entanglement also invites a broader dialogue about humanity's role as we step into this new cosmic frontier. Just as we shape our tools, so too do our tools shape us. The potential for instantaneous communication could deepen our understanding of life beyond Earth, connecting us not only with machines but potentially with other intelligent civilizations. The dialogue could extend beyond our planet, inviting a new chapter in interstellar communication that could redefine our place in the universe. As we forge ahead, the intersection of quantum mechanics and our journey into space stands as a testament to human ingenuity. It reminds us that, as we explore the cosmos, we are also exploring the depths of our own understanding. The very fabric of the universe is rich with possibilities waiting to be uncovered. Quantum entanglement is not just a scientific breakthrough, it is a bridge to our future, facilitating connections that were once thought impossible. In embracing this leap, we are not merely expanding our technological arsenal, we are unlocking a deeper relationship with the cosmos itself. By intertwining our destinies with the quantum world, we set the stage for a new era of exploration where the mysteries of the universe become less daunting and more navigable. With each advancement, the stars come closer, and our dreams of cosmic exploration shift from abstract aspirations to tangible realities. As we prepare for the next phase of our journey, the power of quantum entanglement stands as a beacon, guiding us toward the uncharted and the extraordinary. As we delve deeper into the realm of possibilities, we encounter the next pivotal chapter in our quest for the stars, propulsion breakthroughs that promise to redefine our understanding of travel beyond our home planet. The vastness of space, once a wall between us and other worlds, now appears as a bridge, waiting to be crossed with innovative technologies. Imagine a future where interplanetary distances shrink, allowing us to traverse the solar system with unprecedented speed and efficiency. This is not science fiction, it is the essence of cutting-edge propulsion systems like ion drives and nuclear thermal propulsion, technologies poised to propel humanity into the cosmic frontier. Ion drives, with their elegance and efficiency, are gaining traction as we look toward Mars and beyond. Unlike traditional rockets that rely on chemical propellants, ion engines operate on the principle of ionizing a gas, usually xenon, and expelling these charged particles to produce thrust. This method of propulsion is not only remarkably fuel efficient but also allows for sustained acceleration over long durations. While a chemical rocket may offer a powerful initial thrust, an ion drive can continue to build speed gradually, potentially reaching astronomical velocities over time. Envision a spacecraft darting across the expanse of space, its engines humming quietly as it glides toward distant planets, propelled by the very essence of electricity and physics. The implications of ion drive technology are profound. A mission to Mars, previously a marathon of months, could be shortened significantly, allowing astronauts to spend more time exploring the Martian surface rather than enduring the lengthy journey. With an ion drive, the journey itself transforms from a tedious trek into an adventure, filled with opportunities for scientific discovery and exploration. This technology not only minimizes the payload requirements but also reduces the need for large amounts of fuel, enhancing the feasibility of deep space missions. As these propulsion systems evolve, they could pave the way for the first human footsteps on Mars, with the hope of establishing a lasting presence on the red planet.
Parallel to the advancements in ion propulsion lies the promising realm of nuclear thermal propulsion.
This technology harnesses the immense energy released from nuclear reactions, creating a powerful and efficient means of travel through space. By heating a propellant, such as hydrogen, using a nuclear reactor, these engines can produce a high thrust-to-weight ratio, making them ideal for deep space missions. The beauty of nuclear thermal propulsion lies not only in its power but also in its endurance. Unlike conventional chemical rockets, which burn out quickly, nuclear thermal systems can operate for extended periods, allowing spacecraft to reach destinations that were once deemed unapproachable. Picture a spacecraft equipped with a nuclear thermal engine, roaring toward the outer planets with acceleration that feels almost exhilarating. Such technology could revolutionize our approach to deep space exploration, making trips to the gas giants or even the icy moons of the outer solar system feasible within a human lifetime. The potential for this technology to enable swift journeys to distant worlds opens a treasure trove of opportunities for scientific inquiry, whether it be studying the atmospheres of distant planets or investigating the potential habitability of moons like Europa or Enceladus. As we stand on the brink of these propulsion technology breakthroughs, we cannot help but wonder about the implications for humanity as a whole. With the ability to travel deeper into space, we open ourselves up to new discoveries that could reshape our understanding of life beyond Earth. The search for extraterrestrial life, once confined to telescopes and theoretical models, could transform into tangible exploration as we send spacecraft to investigate the potential of life in unfamiliar environments.
Moreover, the prospect of interstellar travel, once a mere dream, becomes increasingly tangible as propulsion technologies advance.
Imagine humanity, armed with the knowledge and power to traverse the vast gulfs between stars, embarking on journeys that span not just years, but generations. As we innovate our engines, we inch closer to the possibility of reaching exoplanets, worlds that orbit distant suns. These planets, some of which may lie within the Goldilocks zone, present tantalizing opportunities for discovering life-sustaining environments that mirror our own Earth.
Yet, with great power comes immense responsibility.
As we venture further into the cosmos, we must grapple with the ethical considerations of our explorations.
The drive to colonize or explore new worlds invites questions about our role in the universe. Do we have the right to alter other planets, and what will it mean for the beings, if they exist, on those worlds? The technology we develop to traverse space must not only serve our aspirations but also reflect our duty to respect and understand the environments we encounter. In this new era of exploration, the collaboration between nations, institutions, and even private enterprises will be paramount.
As propulsion technologies evolve, fostering a spirit of cooperation can ensure that the journey to the stars becomes a shared endeavor, a collective human experience that transcends borders and ideologies. Together, we can build the engines that will carry us forth, transforming our cosmic dreams into a shared reality. As we continue to unlock the secrets of propulsion technologies, we stand ready to embrace the next phase of humanity's journey into the stars, where the vast unknown beckons, and every leap forward is another step toward a brighter future in the cosmos. With propulsion breakthroughs illuminating our path, the call of the universe grows ever louder, urging us to explore, to discover, and to dream beyond the stars. As we embark on this exhilarating voyage into the cosmos, one of the most profound challenges we face is how to power our ambitions on such a grand scale. The energy demands of interstellar travel are staggering, surpassing anything we have ever encountered. To truly realize our cosmic dreams, we must tap into advanced energy sources that are as revolutionary as the technologies propelling us through space. This quest leads us to the very heart of the universe's mightiest forces, nuclear fusion and antimatter. Imagine harnessing the same process that fuels the sun, a star that has bathed our planet in life-giving warmth for billions of years.
Fusion, the fusing of atomic nuclei to release energy, offers a tantalizing glimpse into the future. On Earth, scientists are racing to decode the secrets of this process, aiming to create a sustainable and virtually limitless energy source. If we can master fusion, we could generate vast amounts of power without the perilous byproducts of fossil fuels or the long-lived waste associated with traditional nuclear fission. Picture a spacecraft powered by fusion reactors, propelling us through the void, carrying enough energy to sustain entire colonies, and enabling us to venture deeper into the cosmos than ever before. The implications of fusion energy extend beyond mere propulsion. With an energy output that dwarfs our current capabilities, fusion could power life support systems, agriculture, and even manufacturing in space. Entire ecosystems could flourish aboard spacecraft or colonies on other planets, creating new havens for humanity far removed from Earth. This energy revolution could redefine our relationship with the universe, allowing us to cultivate new worlds and sustain our species as we branch out into the stars. However, the dream of fusion is accompanied by immense technical challenges. Building reactors capable of achieving the necessary conditions for fusion is no small feat. Scientists are experimenting with magnetic confinement and inertial confinement techniques, seeking to contain and compress plasma at temperatures hotter than the sun itself. Projects like ITER, an international collaborative effort in France, are shining beacons of hope, but the road to practical fusion energy is fraught with hurdles. As we inch closer to a breakthrough, we must remain patient yet resolute, pushing the boundaries of what is possible. Then, there is antimatter, a substance so exotic that it often sounds like the stuff of science fiction. When matter and antimatter meet, they annihilate each other, releasing an incomprehensible amount of energy in the process. Just a gram of antimatter could yield the same energy as a nuclear bomb. The potential applications are staggering, from powering spacecraft at unprecedented speeds to enabling deep space missions that could reach distant worlds in mere months rather than decades. Yet, producing antimatter is extraordinarily difficult and prohibitively expensive. Current methods yield only tiny amounts, and storing antimatter is a feat in itself, as it must be kept away from any matter to prevent annihilation. Research facilities, like CERN, are at the forefront of antimatter studies, but a viable technology for its production and storage remains elusive. Nonetheless, the quest for antimatter fuels our imagination and science, pushing us to explore the limits of our understanding and technology. As we ponder these energy sources, we must also consider how to harness energy from our own star, the Sun. Solar power has advanced tremendously, and space-based solar panels could gather energy free from atmospheric interference, beaming it back to Earth or powering spacecraft directly. These solar farms in orbit could serve as energy hubs, powering colonies on the Moon or Mars. This approach offers a sustainable and abundant energy solution, merging our renewable ambitions with our cosmic endeavors. In contemplating energy from the stars, we also encounter the vast potential of stellar resources. The concept of mining asteroids for their rich metallic and mineral content opens an avenue for energy production. Hydrogen extracted from these celestial bodies could fuel fusion reactions, while rare materials might be transformed into efficient energy systems. As we extend our reach into the solar system, these resources could become vital to sustaining human life on distant worlds, giving rise to a new economy that thrives beyond our planet. This exploration of energy sources is not merely a matter of technological advancement, it also poses profound questions about our future. As we stand on the brink of this new era, we must grapple with the ethical implications of our energy choices. Who will control these resources? How do we ensure they are used responsibly and for the benefit of all humankind? Engaging with these questions will shape our journey, ensuring that as we reach for the stars, we also uphold the values that define us as a species. Energy from the stars is not just about propelling spacecraft, it is a pivotal element in humanity's larger narrative, a narrative that intertwines technology, ethics, and the very essence of what it means to explore. As we harness these powerful sources, we are not merely seeking to expand our physical territory, we are crafting our legacy in the cosmos, striving to become stewards of the universe rather than conquerors. With each step we take toward mastering these energy sources, we illuminate the path that lies ahead, a path filled with promise and potential. As we prepare to venture forth, fueled by the very forces that govern the universe, we embrace the unknown with a sense of wonder, ready to discover what lies beyond, and to redefine our place in the cosmos.
the stars await, and with them, the energy to fuel our dreams. As we gaze into the cosmos, we are captivated by the thought of transforming barren worlds into lush, habitable realms. Terraforming, the art and science of engineering planets to resemble Earth, represents one of humanity's boldest aspirations. Imagine a future where we can turn the dry, arid landscapes of Mars into vibrant ecosystems, or where the clouds of Venus could be reshaped to nurture life. The concept of terraforming may sound like the stuff of science fiction, yet it is grounded in scientific principles that beckon us to dream even larger. At its core, terraforming involves altering a planet's atmosphere, temperature, and surface to create conditions suitable for human life. The first step often discussed is the introduction of gases that could help create a breathable atmosphere. For example, Mars, with its thin atmosphere composed mostly of carbon dioxide, presents a unique challenge. One proposed method involves releasing greenhouse gases to warm the planet, possibly achieved through the deployment of powerful satellites that could reflect sunlight or even bombard the surface with asteroids to release trapped carbon. Once the temperature begins to rise, the next phase could involve the introduction of microorganisms capable of photosynthesis. These tiny pioneers could convert carbon dioxide into oxygen, gradually thickening the atmosphere and making it more hospitable. This biological intervention not only lays the groundwork for a breathable atmosphere but sets the stage for more complex ecosystems to flourish. The delicate interplay between climate, biology, and geology is at the heart of terraforming, and its success hinges on our understanding of these systems. Moving beyond just creating an atmosphere, we dive into the importance of water, one of life's most essential ingredients. Mars holds vast reserves of water ice, locked away beneath its surface and at its polar caps. A key challenge is to find methods to release this water, perhaps by redirecting comets or asteroids to impact the surface, creating lakes and rivers where none existed. With water, the prospect of living organisms takes a more tangible form. Plants could take root, introducing a rich tapestry of life that would, in turn, support higher forms of life, including humans. Imagine a terraformed Mars, where the horizon is dotted with green landscapes, rivers meander through valleys, and the air is filled with the sounds of life. Yet, this vision of a verdant planet is not without its challenges. The process of terraforming could take centuries or even millennia, and the sheer scale of engineering required is daunting. The ethics of such grand designs also come into play. Should we even attempt to sculpt other worlds to match our own? What rights do these planets have? As we ponder these questions, we also consider the technology that will enable these transformations. Advances in biotechnology can help us design resilient organisms that can thrive in extreme conditions, while innovations in materials science will allow us to build structures capable of withstanding harsh environments. Robotics and automation play a crucial role as well, allowing us to deploy and maintain terraforming technology in places where humans cannot yet venture. And then there's the tantalizing prospect of terraforming other celestial bodies. The clouds of Venus, rich in carbon dioxide and sulfuric acid, could be transformed into a paradise. Some scientists propose using floating cities, suspended in the thick atmosphere, to manufacture fuels and other resources. The very nature of Venus's atmosphere could also be repurposed to create a more Earth-like environment, though this remains an enormous challenge, fraught with complexity. Terraforming is not merely a technical endeavor, it's a reflection of our desire to expand the boundaries of human experience. It speaks to our innate drive to explore and adapt, to seek out new frontiers beyond our home planet. Each step we take in this direction is a testament to our ingenuity and determination. As we navigate the intricacies of this science, we must also embrace the unknown consequences of our actions. The potential for unforeseen ecological impacts is real. Creating a new ecosystem means we must tread carefully. Consider the implications of our earthly experiences in shaping our approach to new worlds. On Earth, we have witnessed the fragility of ecosystems and the intricate balance required to maintain them. Our terraforming efforts must be informed by this knowledge, guiding us towards sustainable practices that enhance rather than harm. The act of creating life on another planet is an extraordinary responsibility, one that requires humility and foresight. Yet, the potential rewards are nothing short of breathtaking. A successfully terraformed planet could become a new home for humanity, a second chance for our species to thrive in a universe teeming with possibilities. It opens the door to exploration, to resource gathering, and even to the potential for interstellar travel. Each new world we cultivate could serve as a stepping stone to the stars, a launchpad for a future where we are not confined to our blue planet but are instead a multi-planetary civilization. As we stand on the precipice of this new frontier, the vision of terraforming beckons us with a profound promise. It invites us to dream bigger, to expand our horizons, and to consider not only what we can achieve but what it means to be caretakers of the universe. It challenges our understanding of life, pushing us to redefine our role in the grand tapestry of existence. Through our ambition, we may one day breathe the air of new worlds and gaze upon landscapes crafted by our own hands. The journey of transforming other planets is as much about the evolution of humanity as it is about the destiny of those worlds waiting to be reborn. As we prepare to take our first steps into the vast unknown, a powerful ally stands ready to accompany us on this journey: artificial intelligence. Imagine a partner that not only enhances our capabilities but also extends our reach into the cosmos beyond what we could ever achieve alone. This alliance between humans and AI is set to revolutionize how we explore, inhabit, and understand the universe. Artificial intelligence is not merely another tool in our arsenal, it represents a paradigm shift in our approach to space exploration. With the ability to process vast amounts of data and learn from complex patterns, AI can analyze celestial bodies, identify potential landing sites, and predict environmental changes on distant planets with incredible accuracy. This intelligence will guide our missions, allowing us to make informed decisions in real time, adapting to the unpredictable challenges of space. Consider the intricacies involved in landing a spacecraft on Mars. The delicate choreography of descent, landing, and the immediate deployment of scientific instruments requires precision and speed. AI can autonomously navigate these processes, interpreting sensor data and executing maneuvers at lightning speed, far beyond human reaction times. This capability allows us to explore environments that are challenging or even hazardous. In the not-so-distant future, we will see AI-driven robots playing vital roles on other planets. These autonomous systems will be equipped with advanced sensors and learning algorithms, allowing them to carry out complex tasks, such as building habitats, conducting experiments, or even extracting resources. Picture a fleet of AI drones, surveying the terrain and gathering data long before humans arrive, laying the groundwork for our first colonies on new worlds. These robotic pioneers will pave the way for human explorers, ensuring that when we step onto the surface, we do so with knowledge and preparation. Furthermore, AI will augment our human capabilities in profound ways. By analyzing data from our senses and enhancing our cognitive abilities, AI can help us adapt to life in environments that are alien to our biology. Imagine wearing augmented reality visors powered by AI, which not only provide critical information about our surroundings but also enhance our perception of the environment. In challenging conditions, these systems could analyze atmospheric composition in real time, warn us of hazards, and even suggest optimal actions to take, effectively acting as our eyes and ears in the cosmos. As we journey further into space, the adaptability of AI will become increasingly crucial. Each celestial body presents its own unique challenges, and the ability of AI to learn and evolve will be vital. Whether on the ice-covered moons of Jupiter or the dry, dusty surfaces of Mars, AI algorithms can adapt to new environments, refining their strategies and improving the efficiency of our missions. Through machine learning, AI will not only assist us but will also grow in understanding, becoming a vital partner in our exploration efforts. Yet, this partnership raises important questions about the nature of intelligence and consciousness. As we develop more advanced AI systems, we must consider their role in our society and the ethical implications of our reliance on them. What does it mean to share our journey with an entity that may surpass human intelligence in certain capabilities? How will this affect our decision-making processes and our understanding of what it means to be human? The relationship between humans and AI in space exploration forces us to reflect on our own humanity. In many ways, AI serves as a mirror, reflecting our aspirations, our fears, and our values. As we teach these systems to learn, adapt, and collaborate, we must ensure that they embody the principles we hold dear: curiosity, compassion, and respect for all forms of life. It is our responsibility to create AI that not only enhances our journey but aligns with our ideals. The integration of AI into space exploration also extends to our search for extraterrestrial life. AI can sift through colossal datasets gathered from telescopes and rovers, identifying patterns and anomalies that might indicate the presence of life beyond Earth. It can help us analyze signals from distant civilizations, helping us decipher messages that could change our understanding of existence itself. In this way, AI is not just a tool, it is a partner in our quest for knowledge and connection within the vast cosmic landscape. As we look forward to the new frontiers that await us, we must recognize the immense potential that lies in our partnership with AI. Together, we can unlock the mysteries of the universe, each discovery bringing us closer to understanding our place within it. With AI by our side, we will push the boundaries of exploration, making the seemingly impossible attainable. The journey to the stars is no longer a solitary endeavor. With the combined strength of human creativity and AI-driven intelligence, we stand on the brink of a new era. As we embark on missions to distant worlds, we will do so not just as explorers, but as co-creators of a vibrant future, one where our cosmic partners help illuminate the path forward.
The stars beckon us, and with AI as our ally, we are poised to embrace the adventure that lies ahead, transforming our dreams into reality as we reach for the infinite. As we stand on the brink of interplanetary expansion, a profound question arises: what are the ethical implications of colonizing other planets?
This moment in history is not just about exploring the unknown, it also brings with it a host of moral responsibilities that we must grapple with. The urge to reach out to the cosmos is a reflection of our innate desire to seek new frontiers. Yet, with this pursuit comes the weight of stewardship, a duty to ensure that our exploration does not repeat the mistakes of the past. Throughout history, human expansion has often led to the exploitation of resources and the disregard for indigenous cultures. As we contemplate the colonization of other worlds, we must ask ourselves, do we have the right to claim these celestial bodies as our own? The ethical landscape is far more complex than it may initially appear. The cosmos is not a blank canvas awaiting our brushstrokes, it is a vast tapestry of potential ecosystems, each with its own unique history and significance. We must consider not only the physical realities of these worlds but also the potential life forms that may exist there, whether they are microbial or more advanced. The concept of planetary protection serves as a guiding principle as we venture beyond Earth. This philosophy promotes the idea that we should act responsibly to avoid contaminating other planets with Earth life and, conversely, shield our own biosphere from extraterrestrial entities. How we approach this delicate balance will define our legacy as a spacefaring civilization. It challenges us to develop ethical frameworks that prioritize respect for other worlds and their potential inhabitants. In addition to planetary protection, we must also think about the implications of terraforming. The idea of transforming a barren planet into a habitable environment is tantalizing, yet it raises critical questions. If we alter an entire ecosystem, are we not imposing our will on a world that may have its own intrinsic value? The ethical dilemmas become even more pronounced when we consider the possibility of life already existing on these planets. The balance between enhancing our survival and respecting the sanctity of other life forms is a tightrope we must walk with care. Moreover, as we engage in this cosmic venture, we must acknowledge the socio-political implications of space colonization. Who gets to decide who goes to these new worlds? The potential for inequality is stark. Space should not become a privilege of the wealthy or a select few, it must be an endeavor that embraces diversity and inclusivity. This is an opportunity to redefine our societal structures, ensuring that access to new frontiers is equitable and represents the rich tapestry of humanity. As we expand our horizons, the role of technology also comes into play. Advanced robotics and artificial intelligence can assist in establishing colonies, but we must remain vigilant about the ethical implications of their deployment. These technologies will be our tools, but they must be guided by human values. We are called to ensure that our creations don't perpetuate harm or injustice, either in our interactions with existing ecosystems or among ourselves as we build new communities. Artificial intelligence, in particular, poses unique challenges. As our partners in exploration, we should consider the rights of these entities as they grow more advanced. If AI becomes sentient, how will we navigate our responsibilities towards them? This relationship will require a framework of ethics that respects their autonomy while still upholding our own moral considerations. Interplanetary colonization also presents opportunities for unprecedented international cooperation.
The vastness of space can unite nations, transcending borders and conflicts in the pursuit of common goals.
Treaties and agreements will need to be forged, creating an ethical foundation that governs our interactions with one another and with the cosmos. This global perspective is vital, as the challenges we face in ensuring responsible expansion require collective action. Yet, amidst the excitement of interstellar ambitions, we must remain grounded in the realities of our own planet. The lessons learned from Earth, where environmental degradation and social injustices persist, must inform our future actions. We cannot escape our responsibilities here at home. As we seek to colonize other worlds, we must also prioritize the stewardship of our own planet. Sustainability should be the cornerstone of our exploration, ensuring that we do not replicate the destructive patterns of our past. Looking ahead, the ethics of space colonization will demand ongoing dialogue and reflection. As we develop new technologies and push the boundaries of exploration, we will need to continually reassess our values and principles. This journey into the stars is not just a quest for knowledge or survival, it is a profound opportunity for growth as a species. Our ethical framework will serve as our compass, guiding us through the uncharted waters of this cosmic endeavor. In our pursuit of the stars, we must embrace the responsibility that comes with exploration. The ethical dimensions of space colonization will shape not only our actions in the cosmos but also the very essence of what it means to be human. As we redefine our relationship with the universe, let us do so with humility, compassion, and an unwavering respect for all forms of life. Each step forward must be taken with the understanding that we are not merely visitors in the cosmos, but custodians of a shared destiny. In this cosmic journey, the future is not predetermined, it is a canvas upon which we will paint the legacy of humanity. As we embark further into the cosmos, the role of robotics and autonomous systems becomes increasingly critical. These advanced machines, capable of operating in the most inhospitable environments, are not just tools, they are our eyes, ears, and hands in the vast unknown. Imagine sending a robotic scout to the icy plains of Europa or the dusty canyons of Mars, equipped with sensors that can analyze soil samples, measure atmospheric conditions, and even search for signs of life. These robotic explorers not only extend our reach but also ensure that we can gather invaluable data before we set foot on these distant worlds. Robotics are essential in reducing the risks that come with human exploration. The harsh conditions of space, with its radiation, extreme temperatures, and vacuum, pose significant challenges to human life. By deploying autonomous systems, we can conduct preliminary assessments and prepare sites for future human habitation. These machines can build habitats, extract resources, and even generate oxygen, creating a foundation for human presence without putting lives at risk. This approach allows us to establish a foothold in space, transforming the landscape of interstellar exploration into a more manageable endeavor. One of the most fascinating developments in this field is the advent of autonomous rovers and drones. Picture a fleet of agile rovers scuttling across the surface of Mars, working tirelessly to analyze the geological features, searching for water, and even digging beneath the surface for signs of ancient microbial life. These rovers can communicate with one another, sharing data and adapting their strategies based on real-time findings. With advancements in artificial intelligence, they can learn from their experiences, improving their efficiency and effectiveness as they explore the Martian terrain. Drones, too, have a pivotal role to play. With their ability to traverse the skies of alien worlds, they can scout for resources, survey landscapes, and conduct atmospheric studies. Imagine deploying a drone to fly over the methane lakes of Titan, capturing stunning imagery and gathering data that could unlock the secrets of this enigmatic moon. These aerial explorers can cover vast areas in a fraction of the time it would take a rover, making them indispensable allies in our quest to understand the cosmos. But the potential of robotics doesn't end with exploration. As we look to establish human colonies on other planets, we must consider the continuous support these autonomous systems can provide. From constructing habitats with advanced 3D printing technologies to maintaining life support systems, robots will play an essential role in ensuring that human outposts thrive. They can monitor environmental conditions, manage vital resources, and even assist in agricultural efforts, growing food in alien soils. This synergy between humans and robots will be paramount in overcoming the myriad challenges of space colonization. Moreover, the development of robotic systems is not limited to planetary surfaces. In the depths of space, autonomous spacecraft could revolutionize our approach to exploration. Picture fleets of lightsail probes riding solar winds toward distant star systems, equipped with intelligent navigation systems that allow them to make real-time decisions. These probes could send back data on exoplanets, analyzing their atmospheres and assessing their habitability, all while charting a course for the next destination. With the ability to operate independently over vast distances, such systems could uncover the mysteries of the universe far beyond what we can achieve with human crews alone. As we integrate these technologies, the question of collaboration arises. Robotics in space is not merely about replacing human effort but enhancing our capabilities. The partnership between humans and machines can lead to unprecedented discoveries. Imagine a future where astronauts work side by side with robots, each complementing the other's strengths. While humans bring creativity and intuition, robots provide precision and the ability to operate under extreme conditions. This collaborative spirit could lead to breakthroughs in science and exploration, pushing the boundaries of our understanding of the universe. However, with great power comes great responsibility. As we deploy these autonomous systems, we must grapple with the ethical implications of their use. Decisions made by robotic systems could potentially impact the ecosystems of other worlds or even the safety of space travelers. Establishing guidelines and ethical frameworks for the use of robotics in space exploration is critical. We must ensure that these technologies are used thoughtfully and responsibly, minimizing harm to the environments we explore and respecting the potential for life beyond Earth. The evolution of robotics and autonomous systems is a testament to our ingenuity, our drive, and our unquenchable thirst for knowledge. As we stand on the brink of an era defined by exploration and discovery, we must harness the power of these innovations to illuminate the far reaches of the cosmos. The journey to the stars is not a solitary affair, but a collective endeavor that bridges technology and humanity. In this cosmic odyssey, robots will not only be our tools but our partners, guiding us through the mysteries of the universe and opening new doors to understanding our place within it. As we look to the stars, we can take solace in knowing that with every robotic advance, we inch closer to the reality of human presence on alien worlds, ready to write the next chapter in the grand story of exploration. Each mission, powered by our collective creativity and technological prowess, brings us one step closer to the dream of becoming a multiplanetary species, forever changing the narrative of humanity's journey through the cosmos. As we prepare to transcend the bounds of our home planet, the role of biotechnology emerges as a crucial ally in our quest for survival and prosperity in the unforgiving environments of space. Imagine stepping onto the surface of Mars or another distant moon, where the atmosphere is thin, radiation levels are high, and the landscape is alien. Here, the question of how to sustain human life becomes paramount. Biotechnology offers transformative solutions that could not only help us endure but also thrive in these harsh conditions, turning the inhospitable into the habitable. At the heart of this biotechnology revolution lies genetic engineering, a powerful tool that could modify human biology itself. By understanding the human genome, scientists can potentially develop genetic enhancements that prepare our bodies for the challenges of extraterrestrial living. Imagine being able to fortify ourselves against cosmic radiation through modified DNA, reducing the risk of cancer or other radiation-induced diseases. This could be accomplished by infusing our cells with protective properties derived from extremophiles, organisms that thrive in the most extreme environments on Earth. Such advancements could make human beings more resilient to the rigors of space travel, allowing us to live and work on alien worlds with reduced risk to our health. The potential of biotechnology extends beyond human modifications. It also encompasses the design of life support systems that mimic Earth's ecosystems. By incorporating advanced bioengineering, we can create closed-loop systems capable of recycling air and water, growing food, and supporting human life in isolation. Imagine compact bioreactors that convert waste into nutrients, enabling sustainable food production in low-gravity environments. These systems could use genetically engineered crops that grow faster and require fewer resources, ensuring that even on distant planets, we can cultivate a piece of Earth. Additionally, biotechnology can play a pivotal role in addressing the psychological challenges of space travel. Long-duration missions can lead to isolation, stress, and mental fatigue. Here, biotechnological advancements in neurobiology could lead to therapeutic interventions that enhance mental well-being. Imagine treatments that could help maintain emotional balance, fostering resilience among astronauts as they navigate the psychological hurdles of life far from home. These innovations not only prepare us for the physical demands of surviving in space but also nurture the human spirit, which is just as vital for our journey. As we consider the terraforming of other planets, biotechnology shines brightly in this endeavor. The ability to manipulate ecosystems is not just about creating livable conditions, it's about nurturing life on a planetary scale. By using engineered microbes that can survive in harsh environments, we could begin the process of transforming Mars' atmosphere to make it more Earth-like. These microbes could produce oxygen and organic compounds, gradually creating a more hospitable environment. The dream of walking on a vibrant, green Mars becomes less a fantasy and more a possibility grounded in science. This vision of using biotechnology to support human life in space also extends to healthcare. On long missions, medical emergencies can pose significant risks. Advanced biotechnological solutions could revolutionize healthcare in space, allowing for rapid, on-site diagnostics and treatments. Imagine handheld devices capable of genetically analyzing pathogens and providing personalized medical solutions, ensuring that astronauts receive the best possible care without needing to return to Earth. With biotechnology, we can prepare for health challenges that arise in alien environments, making space travel safer and more sustainable. But as we advance our biotechnological capabilities, we must navigate the ethical implications that accompany such power. The notion of altering human biology and ecosystems raises profound questions. How do we ensure that our modifications are safe and equitable? What responsibilities do we have toward the ecosystems we are transforming? As we create life support systems and modify our own biology for extraterrestrial environments, we must tread carefully, embracing innovation while respecting the delicate balance of life. In parallel to these advancements, the integration of biotechnology with artificial intelligence and robotics could yield remarkable synergies. Imagine robots that not only assist with tasks but also possess biological components capable of adaptive responses to their environment. These hybrid systems could monitor human health, manage life support functions, and even assist in terraforming efforts, all while learning from their experiences to improve efficiency. This convergence of technology and biology could redefine our approach to space exploration, enabling us to create environments that are not just survivable but flourishing. The universe holds countless mysteries, and with advancements in biotechnology, we are better equipped to unravel them. Our expanding toolkit allows us to explore not just the surface of alien worlds but the very fabric of life itself. As we look to the stars, the intersection of biotechnology and space exploration offers a glimpse of a future where humans not only journey to other worlds but do so with the tools necessary to sustain life, protect our health, and even cultivate new ecosystems. Every step forward in this field invigorates our cosmic dream. With each breakthrough, we are reminded that the journey into the stars is not merely about exploration, it is about ensuring the survival of our species as we forge new paths across the cosmos. Biotechnology stands at the forefront of this transformation, unlocking possibilities that were once confined to the realm of science fiction. With these innovations, we are not just voyagers but gardeners of the universe, planting the seeds of life wherever our dreams take us. As we continue our expedition into the great beyond, humanity's journey evolves, rooted in the very essence of life itself. As we venture deeper into the cosmos, the integration of virtual and augmented reality technologies emerges as a pivotal element in shaping the experiences of astronauts and future space settlers. Imagine a world where the vastness of space is not just seen, but felt and interacted with in immersive ways. Virtual reality transports us into environments that simulate the conditions of distant planets, allowing astronauts to train in scenarios that mirror the challenges they will face. This rich, simulated experience is invaluable for honing skills and preparing for the unknown. Astronauts can walk on the surface of Mars, practice landing maneuvers on an alien terrain, and even conduct experiments in a weightless environment, all without ever leaving Earth. The ability to experience these scenarios in a hyper-realistic setting cultivates a sense of preparedness that is essential for long-duration missions. Training in virtual environments helps astronauts acclimatize to the isolation and confinement of space, providing tools to manage stress and build resilience before the real journey begins. Augmented reality takes this a step further, overlaying crucial information on a user's field of vision in real time. Picture an astronaut floating in the depths of space, with critical data and navigational aids projected directly onto their helmet visor. The seamless integration of digital information enhances situational awareness, making it easier to conduct complex tasks while surrounded by the breathtaking expanse of the universe.
With augmented reality, astronauts are equipped with real-time updates about their equipment, mission objectives, and environmental changes, allowing them to make informed decisions quickly.
These technologies are not just tools for training, they redefine the way we perceive and interact with our cosmic surroundings. Virtual reality can create collaborative environments where teams of scientists and engineers, scattered across different continents, can join together in a shared simulated space. They can manipulate 3D models of spacecraft, simulate mission scenarios, and brainstorm solutions in a way that feels truly immersive. This collaborative aspect fosters innovation and accelerates problem solving, setting the stage for breakthroughs that could alter the course of space exploration. In addition to training and operational support, virtual and augmented reality can enhance public engagement with space exploration. Imagine a future where anyone can don a VR headset and experience the wonders of the universe from their living room. They could soar through the rings of Saturn, navigate the craters of the Moon, or even witness a launch from the Kennedy Space Center. Such experiences would not only inspire the next generation of explorers but also help demystify the complexities of space travel, bringing humanity closer to the stars in ways previously thought impossible. The benefits of these technologies extend to the colonization of other planets as well. When humanity establishes habitats on extraterrestrial worlds, virtual and augmented reality can aid in the construction and maintenance of these new homes. Architects and engineers can visualize structures, conduct virtual walkthroughs, and troubleshoot problems before physical construction begins. This level of preparation can ensure that habitats are not only functional but also comfortable and conducive to human life. Moreover, as we consider the long-term sustainability of life beyond Earth, virtual and augmented reality can play an essential role in education and community building.
Future settlers will need to adapt to entirely new environments and ecosystems.
Through immersive training modules, they can learn to cultivate alien crops, manage resources, and establish social systems that promote cooperation and harmony in their new home. The ability to practice and refine these skills in a virtual setting can lay the groundwork for thriving communities on distant planets. Perhaps most importantly, as we look to the stars, we must also consider the human experience of space exploration. The psychological effects of isolation and the unknown can be profound. Virtual reality can serve as a tool for mental health, providing astronauts with immersive environments that remind them of Earth or allowing them to engage in recreational activities that elevate their spirits. Whether it's hiking through a simulated forest or experiencing a concert with loved ones, these moments of connection can be vital for emotional well-being during long missions. As the boundaries between virtual and physical realities blur, we find ourselves at an intersection of possibility and innovation. The applications of these technologies in space exploration are boundless, reshaping not only how we explore but also how we experience our journey among the stars. By embracing virtual and augmented reality, we embark on a new paradigm of exploration, one where preparation, collaboration, and human connection drive us forward into the depths of the cosmos.
In this unfolding narrative of space exploration, where technology and imagination intertwine, we are not merely observers of the universe. We are active participants in a grand adventure that challenges our perceptions and expands our horizons. As we prepare for the incredible challenges that await us, these groundbreaking tools will ensure that we are equipped not only to survive but to thrive as we chart our course among the stars. The cosmos beckons, and with every leap in technology, we are one step closer to realizing the dreams of generations past. As we journey further into the cosmos, the age-old question of whether we are alone in the universe takes on new urgency and significance. The search for extraterrestrial life is not just a scientific endeavor, it's a profound inquiry into our place in the cosmos. With the advent of emerging technologies, we are now equipped to explore this vast frontier like never before, pushing the boundaries of our understanding and imagination. Imagine standing on the surface of Mars, a world that has captivated humanity's imagination for centuries. With rovers like Perseverance and missions such as the Mars Sample Return, we are actively collecting samples and analyzing the Martian surface for signs of ancient life. These robotic explorers are equipped with sophisticated instruments that allow us to detect organic molecules, analyze the planet's geology, and even study its atmosphere. Each discovery brings us closer to answering the question, did life ever exist on our neighboring red planet? But Mars is just the beginning. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, hold tantalizing possibilities beneath their frozen crusts. With the help of advanced imaging technologies and spectrometers, scientists are investigating the subsurface oceans that may harbor life. These missions represent a leap in our capability to explore environments previously thought inhospitable. They underscore a remarkable truth: life, as we know it, may thrive in the most unexpected places. Emerging technologies are not limited to exploration within our own solar system. The search for exoplanets, planets orbiting stars beyond our Sun, has taken a giant leap forward thanks to space telescopes like Kepler and TESS. These instruments employ intricate techniques to detect distant worlds, analyzing their atmospheres and potential habitability. By gathering immense amounts of data, we can identify planets in the so-called Goldilocks zone, where conditions might be just right for liquid water and, potentially, life. Artificial intelligence plays a pivotal role in this cosmic search, sifting through vast datasets with remarkable efficiency. Algorithms can analyze light patterns from distant stars to detect the faint signatures of an exoplanet passing in front of its star. With machine learning, researchers are not only identifying new planets but also predicting their characteristics, aiding in the quest to find life-sustaining environments. As we refine our search, we also seek to expand our understanding of what life might look like beyond Earth. Traditional definitions of life often center around carbon-based organisms, but as we explore diverse environments, we must entertain the possibility of life forms that do not fit this mold. Emerging biosignature detection technologies allow us to identify chemical markers that suggest biological processes, broadening our search criteria. With every discovery, we challenge our assumptions and expand our understanding of life's potential diversity. The quest for extraterrestrial intelligence adds another layer to this exploration. Projects like SETI, the search for extraterrestrial intelligence, utilize radio telescopes to scan the cosmos for signals that might indicate advanced civilizations. With advancements in signal processing and data analysis, we are better equipped to listen to the vast silence of the universe, hoping to catch a whisper from an alien world. The development of new technologies allows us to filter through the noise, honing in on potential signals that could reveal the existence of intelligent life beyond Earth. The ethical implications of our search for extraterrestrial life are profound and complex. As we develop the capability to communicate with potential extraterrestrial societies, we must consider the consequences of our actions. What should we say? How should we respond? The pursuit of knowledge must be balanced with wisdom, as our discoveries could have lasting impacts on both humanity and any civilizations we may encounter. The responsibility of this search extends beyond mere curiosity; it encompasses the very essence of our humanity and our role in the universe. Moreover, the implications of discovering life beyond our planet would be transformative. It could reshape our philosophies, religions, and understanding of life itself. It could foster a sense of unity among humanity, as we view ourselves not as isolated beings but as part of a larger cosmic community. The potential for collaboration and exchange of knowledge with extraterrestrial civilizations is a dream that, with every technological advancement, inches closer to reality. As we prepare to extend our reach into the vastness of space, the tools and technologies at our disposal will play a crucial role in this quest. From robust telescopes that peer deep into the universe to innovative spacecraft that traverse the solar system, the fusion of science and technology is paving the way for groundbreaking discoveries. The cosmos is filled with secrets waiting to be uncovered, and as we venture forth, our collective curiosity drives us to explore, discover, and ultimately understand. With each step we take, we reaffirm humanity's place as explorers at heart, driven by an insatiable thirst for knowledge and an unwavering hope in the possibilities that lie ahead. The search for extraterrestrial life is not merely a scientific pursuit, it is a journey that invites us to ponder our origins, our future, and the very essence of existence itself. As we turn our gaze to the stars, we embrace the unknown, ready to unlock the mysteries of the universe and, perhaps, discover we are not alone after all. The cosmic dream continues, and every technological leap brings us closer to realizing it. As we delve deeper into this cosmic dream, one of the most tantalizing concepts that emerges is the idea of space elevators.
Imagine a structure that stretches from the surface of our planet all the way into orbit, a monumental tether connecting Earth to the cosmos. This vision, once relegated to the realm of science fiction, is increasingly seen as a feasible engineering challenge, one that could revolutionize how we access space and reshape our relationship with the universe.
At its core, the design of a space elevator relies on the principle of balance.
The concept is elegantly simple. A long cable, anchored to the Earth's surface, extends upward past geostationary orbit and into space. This cable would need to be incredibly strong, capable of withstanding not just its own weight but also the forces exerted by winds, gravity, and even the occasional impact from space debris. The material requirements are daunting. Current technologies are not yet capable of producing a cable strong enough. However, advancements in materials science, especially with carbon nanotubes and other innovative substances, could pave the way for this dream to become a reality. The mechanics of a space elevator offer extraordinary potential. By utilizing climbers, essentially elevators that ascend the cabled cargo and even passengers could be transported into orbit with minimal energy expenditure. Unlike conventional rockets that require vast amounts of fuel to escape Earth's gravitational pull, a space elevator would leverage the continuous power of electromagnetic propulsion. This shift could significantly reduce the cost of sending payloads into space, making it accessible not just for governments and corporations but for individuals and researchers as well. The implications of such a structure extend far beyond mere affordability.
Imagine a world where launching satellites or initiating deep space missions is as straightforward as taking an escalator to the second floor. This accessibility could lead to an explosion of innovation in space exploration and utilization.
With routine access to low Earth orbit, we could witness the rapid expansion of space industries, from manufacturing in microgravity to the establishment of research facilities that study the effects of long-term space habitation. The possibilities are vast and captivating. Moreover, a space elevator could serve as a hub for various space endeavors. Envision a bustling terminal in the sky, where spacecraft from all corners of the world converge, ready to embark on missions that stretch our understanding of the universe. This could become a launchpad for missions to the Moon, Mars, and beyond, allowing for resupply and upgrades to spacecraft in a way that is currently unfeasible with traditional launch methods. The convenience of a space elevator could turn distant celestial bodies into reachable destinations, transforming our approach to interplanetary travel. Yet, the construction of a space elevator is not without its challenges.
Among the hurdles to overcome is the issue of stability.
The cable must remain taut and centered, which would require precise engineering and real-time adjustments. Factors such as weather, atmospheric conditions, and the rotation of the Earth all play significant roles in maintaining the integrity of this monumental structure.
Additionally, safety concerns must be addressed.
The possibility of space debris colliding with the cable or climbers poses a risk that engineers would need to mitigate carefully.
As we contemplate the future of space elevators, we are also forced to consider their broader implications for humanity. An accessible gateway to space could catalyze a new era of exploration and discovery.
However, this potential also raises questions about the ethics of space colonization and the international governance of such monumental projects.
Who controls access to this new highway to the stars? How do we ensure that the benefits of space exploration are shared equitably across nations and communities? The establishment of a space elevator could also serve as a testament to human ingenuity and collaboration.
Building such a structure will require the collective efforts of scientists, engineers, and thinkers from around the world. This undertaking could unify humanity through a common goal, much like the International Space Station has done, fostering cooperation in a pursuit that transcends borders and cultures. The vision of a space elevator is more than just an engineering marvel. It embodies the spirit of exploration and the relentless human desire to push boundaries. As we grapple with the challenges of our time, climate change, resource scarcity, and social inequality, the prospect of lifting ourselves into the cosmos offers not only hope but also an opportunity for a fresh start. By reaching for the stars, we could redefine our relationship with Earth, using the resources of space to create sustainable solutions for our planet's challenges. In the end, the concept of space elevators encapsulates the essence of our cosmic journey. It reflects our innate desire to explore, to discover, and to understand our place in the universe. With each technological leap, we draw closer to transforming this dream into reality, crafting a future where the stars are no longer distant points of light but attainable destinations. As we stand on the brink of this new frontier, we are reminded that the sky is not the limit, it is merely the beginning of our journey into the boundless expanse of the cosmos. As we contemplate the vastness of the universe, our imagination dances with possibilities that seem drawn from the pages of science fiction. Interstellar travel, the dream of journeying to distant star systems, beckons us with the allure of discovery. Yet, the distances involved are staggering. The nearest star, Proxima Centauri, lies more than 4 light-years away, a journey that, with our current technology, would take tens of thousands of years. To bridge this cosmic chasm, we must envision groundbreaking concepts that could redefine the boundaries of travel. One of the most captivating ideas is the warp drive, a theoretical propulsion system that could allow us to traverse the fabric of spacetime itself. Picture this: rather than moving through space in the traditional sense, a warp drive would contract space in front of a spacecraft while expanding it behind. This manipulation of the spacetime continuum would create a bubble that moves the ship at effective speeds greater than that of light without violating the laws of physics as we currently understand them. In essence, a warp drive could allow us to travel vast distances almost instantaneously, transforming our dreams of visiting other stars into a tangible possibility. The concept of a warp drive is rooted in the equations of general relativity, specifically those proposed by physicist Miguel Alcubierre in 1994. Alcubierre's model suggests that instead of accelerating a spacecraft to the speed of light, we could warp the space around it, creating a shortcut through the cosmos. Although this notion sounds incredibly advanced, the practical challenges are immense. Creating such a device would require exotic matter with negative energy density, something we have yet to discover or create. However, the very existence of these theories ignites our curiosity and propels us toward innovation. Alongside warp drives, wormholes present another tantalizing possibility for interstellar travel. Often described as tunnels through the fabric of spacetime, wormholes could connect 2 distant points in the universe. If stable wormholes exist, they could serve as shortcuts, allowing us to traverse light-years in mere moments. While wormholes have been a staple of science fiction, they also find their roots in theoretical physics, emerging from Einstein's equations of general relativity. However, like warp drives, the stability and traversability of these cosmic gateways remain purely speculative. In theory, a traversable wormhole would require a structure that prevents it from collapsing under gravitational forces, again hinting at the need for exotic forms of matter. If we could harness these natural phenomena, the implications for space exploration would be profound. We could not only reach other star systems in a fraction of the time but also explore potentially habitable planets, seek out new resources, and perhaps even make contact with extraterrestrial civilizations. Yet, with these possibilities comes the weight of responsibility, as our quest for knowledge must be tempered with ethical considerations. While the mechanics of warp drives and wormholes captivate our minds, they also raise profound questions about the nature of our universe and our place within it. As we peer into the unknown, we must consider how we would interact with other worlds and their inhabitants. Would we approach with curiosity and respect, or would we impose our will upon them? The potential for interstellar travel carries with it the burden of not just scientific advancement but moral accountability. As we push the boundaries of what is possible, we are also forging partnerships with artificial intelligence and advanced robotics, allies that will augment our capabilities in this vast cosmic sea. Imagine powerful AI systems guiding us through the complexities of navigating wormholes or assisting in the design of warp drives. These technologies could analyze vast amounts of data and simulate outcomes far beyond our natural abilities, enhancing our journey through the cosmos and ensuring that our aspirations are met with precision and care. Moreover, the search for extraterrestrial life becomes even more urgent and compelling as we dream of interstellar travel. With our eyes set on distant stars, we are not just seeking new worlds to inhabit but also hoping to answer the profound question of whether we are alone in the universe. Every encounter, whether through advanced robotic explorers or through human crewed missions, could bring us one step closer to understanding the intricate tapestry of life that may exist beyond our home planet. But as we envision the pathways to the stars, the concept of a cosmic internet emerges, linking humanity in ways never before imagined. Information could flow effortlessly across light years, allowing us to communicate, share discoveries, and collaborate on a galactic scale. This interconnectedness would not only facilitate exploration but also forge a sense of unity among the diverse communities of Earth, expanding our collective consciousness in ways that reflect the very essence of our journey into the cosmos.
The dream of interstellar travel is no longer confined to the realm of speculation.
As emerging technologies bring us closer to realizing warp drives and harnessing wormholes, we equip ourselves with the tools necessary for this grand adventure. Every leap in understanding, every technological breakthrough, moves us toward the stars, fueling our quest for knowledge and our desire to explore. In this wondrous pursuit, we embrace the unknown, prepared to encounter not just uncharted territories but the myriad possibilities that await us. Our journey beyond the familiar reaches of our solar system is a testament to human ingenuity and resilience. With our hearts set on the cosmos and our minds ignited by the discoveries that lie ahead, we take our first steps into a future that promises to be as transformative as it is exhilarating. The stars are not merely destinations, they are destinations filled with potential, discovery, and the ever-expanding horizon of the human experience. As we venture deeper into the cosmos, a new frontier begins to take shape, one that will redefine our understanding of communication, connection, and collaboration across vast distances. Imagine a future where a network of satellites and relay systems transcends the limitations of our current technology, creating a cosmic internet that seamlessly links humanity throughout the solar system and beyond. This isn't just a dream, it's a crucial aspect of our journey to the stars, a gateway to sharing knowledge, resources, and culture in ways we are only beginning to comprehend.
Consider the challenges of communicating across the staggering expanse of space.
Messages sent to Mars, for instance, can take anywhere from 3 to 20 minutes to reach their destination, depending on the alignment of our planets. This delay can make real-time interactions nearly impossible, transforming our conversations into a series of delayed exchanges.
However, a cosmic internet could alter this dynamic entirely.
Envision a constellation of satellites orbiting planets and moons, forming a web of connections that relay messages almost instantaneously, allowing researchers and explorers to collaborate in real time, regardless of their physical location in the solar system.
This advanced communication network would not only enhance our ability to communicate but would also serve as a backbone for the burgeoning colonies we hope to establish on other celestial bodies. With each outpost equipped with robust communication systems, humanity could share vital data on agriculture, resource management, and environmental conditions, ensuring that even the most remote settlements do not become isolated. The potential for shared learning could accelerate our adaptation to extraterrestrial environments, transforming challenges into opportunities. The cosmic internet would also enable a new era of scientific discovery.
Imagine a scenario where data from multiple missions is aggregated and analyzed instantaneously, creating a global repository of information about asteroids, distant exoplanets, and even the conditions of life beyond Earth. This interconnectedness would allow scientists to collaborate across light years, piecing together the mysteries of the universe with a speed and efficiency previously thought impossible.
With this network, the collective knowledge of humanity would expand exponentially, each new discovery building upon the last, ultimately leading to profound insights into our place in the cosmos. Moreover, as we continue to explore the universe, the cosmic internet will play a vital role in ensuring the safety and security of our missions.
By leveraging advanced AI algorithms, satellites could monitor space debris and identify potential hazards in real time, providing critical information to spacecraft navigating through the vastness of space. This proactive approach to communication and monitoring would not only protect our explorers but would also foster a culture of collaboration and shared responsibility among nations and organizations venturing into the unknown. In this web of connectivity, the social fabric of humanity would also evolve. As we connect with fellow explorers across the cosmos, our cultural exchanges would flourish. The cosmic internet could facilitate art, music, and literature that transcends planetary boundaries, allowing us to share stories and ideas in ways that resonate across distances. Just as the internet has transformed our world by connecting individuals and communities, the cosmic internet could weave together a tapestry of human experience that spans the solar system, enriching our understanding of what it means to be human in a cosmic context. However, with the promise of a cosmic internet comes a host of ethical considerations. As we forge this network, we must grapple with questions about access and equity.
Who gets to connect, and who might be left behind? Our exploration of space should not replicate the injustices and inequalities of Earth.
Instead, we have an opportunity to create a system that is inclusive and fair, ensuring that all of humanity can benefit from this leap into the cosmos.
As we prepare to build this cosmic internet, we will also need to look carefully at the technologies that will power it.
Advances in quantum communication, for instance, could play a pivotal role in ensuring secure and instantaneous connections across vast distances. This technology leverages the principles of quantum entanglement, enabling the transmission of information in ways that are fundamentally different from our current methods. By harnessing the power of the quantum realm, we could create a communication network that is not only faster but also more secure, protecting our data as we share it across the universe. Looking ahead, the cosmic internet could become an integral part of our daily lives, even as we expand our existence beyond Earth. Just as the internet has revolutionized how we access information and connect with one another, this new network could redefine how we engage with the cosmos. Imagine a future where you could virtually explore the surface of Mars, participate in an interactive seminar with scientists on the Moon, or attend a concert broadcast live from a space station orbiting Earth. The possibilities are as vast as space itself. In embracing this vision, we must remember that the cosmic internet is not merely a technological advancement, it is a reflection of our aspirations as a species. It symbolizes our desire to connect, to learn, and to thrive together in a universe filled with wonder and potential. As we forge ahead, let us harness this incredible opportunity to build a future where every voice can be heard, every story can be told, and every exploration can be shared, weaving a collective narrative that stretches from our home planet to the farthest reaches of our solar system and beyond. In this new age of connectivity, we find not just a path to the stars but a profound extension of what it means to be human in a boundless universe. The prospect of venturing into the cosmos carries with it not only the allure of discovery but also the potential to fundamentally reshape our cultural and societal landscapes. As humanity sets its sights on the stars, we will inevitably find ourselves on a journey that extends beyond the physical act of exploration. It will redefine our identities, alter our values, and transform the very essence of what it means to be part of a global community. Imagine a future where the stars are not just distant points of light but destinations within our reach. The sheer act of exploring other worlds will inspire a new wave of creativity and expression, igniting a renaissance of art, literature, and philosophy. Just as the age of exploration on Earth gave rise to new cultural movements, our foray into space will lead to fresh narratives that reflect our experiences among the stars. Artists will find inspiration in alien landscapes and the mysteries they hold, while writers and filmmakers will weave tales of interstellar journeys, complex alien civilizations, and the ethical dilemmas posed by our expansion into the cosmos. As we navigate this uncharted territory, our collective identity will also undergo a profound transformation. The Earth, once our sole home and focal point, will become one of many stepping stones in our cosmic journey. This shift will encourage a greater sense of unity as we recognize the fragility of our planet and the shared responsibility we have in safeguarding it. The view from space, our beautiful blue planet cradled in the vastness of the cosmos, will serve as a powerful reminder of our interconnectedness. The realization that we are all inhabitants of a tiny speck in an immense universe might foster a deeper appreciation for diversity and a commitment to collaboration over conflict. Societal structures will be challenged and reimagined in the context of space exploration. The need for international cooperation will pave the way for new alliances and partnerships, as countries come together to tackle the complexities of living and working in space. This collaborative spirit could diminish nationalistic barriers, fostering a global identity that transcends borders. With the establishment of space agencies, research hubs, and commercial enterprises, the workforce will expand in ways we can barely envision. New job sectors will emerge, requiring skills that bridge science, technology, engineering, and the arts, creating a vibrant tapestry of collaboration and innovation. Education itself will adapt to meet these evolving needs, emphasizing not only technical prowess but also critical thinking and creativity. The exploration of space will become an integral part of our curricula, inspiring future generations to dream big and consider careers that once seemed the stuff of science fiction. Students will engage in hands-on experiences, perhaps even participating in space missions, igniting a passion for STEM fields while nurturing a sense of responsibility toward the universe at large.
As we venture beyond our atmosphere, the implications for our ethical frameworks will be profound.
Questions surrounding the colonization of other planets will force us to confront our past mistakes and reshape our moral compass. The potential for exploitation of new worlds and resources will call for a re-evaluation of our values.
Will we repeat the patterns of colonialism that marred our history on Earth, or will we approach these new frontiers with wisdom and respect?
The ethical dialogue surrounding space exploration will challenge us to consider the rights of not only our fellow humans but also the ecosystems and potential life forms we may encounter. In this evolving cultural landscape, technology will play a pivotal role in shaping our societal interactions. The rise of virtual and augmented reality will immerse us in experiences that bring the cosmos closer to home. Imagine donning a headset and traversing the surface of Mars or collaborating with a diverse group of individuals from around the world on a simulated mission to an exoplanet. These experiences will not only expand our understanding of the universe but also foster empathy and shared experiences, forging bonds that span across cultures and geographies. Furthermore, as we establish bases on the Moon and Mars, new communities will form, each with its unique culture and identity. These off-world societies will likely develop their own customs, languages, and social norms, contributing to a rich tapestry of human experience. The blending of Earth's diverse cultures with the novel circumstances of extraterrestrial living will create a fascinating fusion, one that could reshape our understanding of community, belonging, and identity in profound ways. The digital renaissance that accompanies our journey to the stars will also give rise to a cosmic internet, enabling instantaneous communication across vast distances. This interconnectedness will not only allow us to share discoveries in real time but will also create a platform for cultural exchange, where stories, art, and ideas can flow freely among Earth's inhabitants and those living in space. The lines between physical and digital communities will blur, creating a dynamic network of human experience that spans across planets. As we gaze up at the night sky, we may begin to see not just twinkling stars, but also the dreams and aspirations of a united humanity reaching out toward the cosmos. This transformation will invite us to redefine our narratives, not merely as Earthlings but as cosmic pioneers, bound together by our shared quest for knowledge, understanding, and connection in an ever-expanding universe. As we prepare for the unknown, let us not only embrace the technology that propels us forward but also the cultural evolution that will redefine our journey from Earth to the stars. As we set our sights on the cosmos, the importance of international collaboration becomes ever more apparent. The challenges we face in our quest for exploration transcend borders and ideologies. They call for a unified approach, reminding us that when we reach for the stars, we do so not as isolated nations, but as inhabitants of a single planet. The vastness of space can only be navigated through the combined efforts of humanity, where diverse perspectives and shared expertise illuminate the path ahead. Imagine a future where nations, each with its unique strengths and capabilities, come together to pool their resources for a common goal. This vision is not merely aspirational, it is becoming a reality. Space agencies around the globe are already forging partnerships that emphasize cooperation over competition. The International Space Station stands as a testament to this spirit of collaboration. Designed and built by multiple nations, it serves as a microcosm of international unity. Astronauts from different backgrounds work side by side, conducting experiments that benefit all of humanity. This collaborative framework lays the groundwork for even bolder ventures, as we prepare to explore the Moon, Mars, and beyond. Moreover, the potential for international collaboration extends far beyond governmental space agencies. Private companies, nonprofits, and academic institutions are also stepping into this arena. The rise of commercial spaceflight has introduced a dynamic element, where innovative startups can partner with established space organizations to push the boundaries of what's possible. By sharing knowledge and technologies, these diverse players can accelerate progress, ensuring that advancements benefit everyone, not just a select few. This collective ingenuity is crucial, especially when addressing the complex challenges of long-term space missions, such as sustainable life support systems or effective radiation shielding. The need for collaboration also resonates in the realm of scientific research. The search for extraterrestrial life, one of humanity's most intriguing quests, is enhanced when scientists across the globe share data and insights. Telescopes and observational missions from different countries work together, allowing us to piece together a more comprehensive understanding of our universe. By combining efforts, we can cast a wider net, exploring more celestial bodies, and increasing our chances of discovering signs of life beyond Earth. Through this collective pursuit, we not only expand our knowledge but also foster a sense of shared responsibility for stewardship of the cosmos. Yet, as we extend our reach into space, we must remain mindful of the ethical considerations that accompany such endeavors.
International collaboration allows us to engage in important discussions about the implications of space colonization. How do we ensure that no one nation monopolizes resources found on other planets? How do we respect the rights of any life forms we may encounter? By working together, we can develop frameworks that promote fairness and justice, ensuring that our actions reflect the best of humanity's values. With the ambitious goal of colonizing other planets on the horizon, the critical role of international cooperation becomes even clearer. Initiatives to terraform planets or establish human habitats in space will require vast resources and diverse expertise. No single nation possesses all the knowledge or technology required for these monumental tasks.
Through international coalitions, we can gather the finest minds in science and engineering, uniting them in a shared mission.
This collaboration will not only expedite our efforts but also fortify our commitment to ethical practices and sustainable approaches as we make new worlds our homes.
As we venture further into the depths of space, we must also cultivate our relationships with countries that might not yet have a prominent presence in the space race.
The democratization of space exploration opens doors for nations traditionally excluded from these dialogues.
By offering mentorship and resources, we can empower emerging spacefaring nations to contribute their unique perspectives and innovations. This inclusivity enriches our collective capabilities and ensures that the legacy of space exploration reflects the diverse tapestry of humanity.
But the journey to the stars is not solely about technology. It is also about culture.
International collaboration fosters cultural exchange, allowing us to learn from each other's histories and philosophies. This deepens our understanding of what it means to be human and enhances our capacity to envision a future where we coexist harmoniously, both on Earth and among the stars. The stories we share and the alliances we form will shape the way we approach challenges and opportunities in our cosmic journey. In the grand tapestry of space exploration, the threads of international collaboration weave a narrative of unity, hope, and shared destiny. As we face the unknown, we find strength not in isolation, but in the bonds we create across borders. Our collective efforts will propel humanity toward a future where exploration and discovery become a shared heritage, transcending the limitations of our individual nations. As we prepare to take our next giant leap, let us nurture the relationships we forge today. By embracing the collaborative spirit, we can harness the full potential of our collective intelligence and creativity, ensuring that our journey from Earth to the stars is not just a bold venture into the unknown, but a reflection of our highest aspirations as a united species. Together, we can unlock the mysteries of the universe and write a new chapter in the story of humanity, one where cooperation lights the way to a brighter, more expansive future. As we stand on the precipice of this new era, preparing for the unknown is both our challenge and our calling. The cosmos is a vast expanse filled with mysteries, some of which may be welcoming, while others could demand our utmost resilience and adaptability. Each mission into the depths of space carries with it the weight of uncertainty. The very essence of exploration is a dance with unpredictability, where every leap we take is both thrilling and daunting. How do we prepare ourselves for the unforeseen challenges that lie ahead? The journey to uncharted territory is not just about the technology we develop, but also about the human spirit that propels us forward. History has shown us time and again that the path of exploration is fraught with peril. From the oceanic voyages of ancient mariners to the ambitious lunar landings of the 20th century, humankind has always faced obstacles that tested our resolve. Yet it is through these trials that we discover our true potential. Every setback, every unexpected turn, becomes a stepping stone toward greater understanding and achievement. Space exploration magnifies these challenges. The harsh environment of outer space is unforgiving. The vacuum, extreme temperatures, and cosmic radiation are just a few of the obstacles we must overcome. As we send missions to Mars, the moons of Jupiter, or even the distant edges of our solar system, we do so with the knowledge that the unexpected can disrupt even the most meticulously laid plans. Our rovers may encounter unanticipated terrain or equipment may fail under conditions we haven't fully anticipated.
Yet, within each of these challenges lies an opportunity for growth, a chance to adapt and innovate. At the heart of humanity's exploration is our remarkable ability to learn. Each mission not only expands our understanding of the universe but deepens our insight into our own limitations and capabilities.
Engineers and scientists are constantly refining their designs, driven by both triumph and failure.
Every time a spacecraft successfully collects data or falters, researchers extract lessons that shape future endeavors.
It is this iterative process of learning that defines us, weaving resilience into the very fabric of our pursuit of the stars.
The human spirit thrives in adversity, transforming fear into courage and uncertainty into hope.
As we prepare for missions that may take us far beyond our familiar horizons, we must cultivate this spirit. Astronauts, scientists, and visionaries are not just embarking on journeys of exploration, they are also pioneers in human resilience. The training they undergo, both physically and mentally, is a testament to our capacity to adapt. Simulations of distant missions push them to their limits, preparing them for the unexpected situations they will inevitably face. In these moments, they become symbols of what it means to venture into the unknown. Moreover, our journey into space is not just about technology and exploration, it is also deeply intertwined with our collective ethical considerations. As we contemplate colonizing other planets or harnessing cosmic resources, we must grapple with the moral responsibilities that accompany such actions. The uncharted territories of space should not only inspire wonder but also invoke caution and reflection. How do we ensure that our exploration serves the greater good? How do we approach new worlds with respect, cognizant of the delicate balance that sustains life? In preparing for the unknown, we must also engage in robust discussions about cooperation and governance. Space is a shared domain, and our missions are not isolated endeavors, they represent humanity's collective ambition. International collaboration is essential as we forge alliances and share knowledge, minimizing the risks that come with venturing into the cosmos. By uniting diverse expertise and perspectives, we enhance our capacity to navigate the unpredictable nature of space travel. Together, we confront the challenges of the universe, transforming them into opportunities for shared progress. Moreover, we cannot overlook the role of mental and emotional resilience in our preparation. The isolation and pressure of space missions can take a toll, influencing not just the physical aspects of exploration, but the psychological dimensions as well. As we send humans into the cosmic frontier, we must prioritize their well-being, developing systems that support mental health and foster a sense of community, even when thousands of miles separate them from home. The bonds forged in these extraordinary circumstances can become lifelines, helping astronauts cope with the unknown while they traverse the vast darkness of space. As we look ahead, we must also embrace the lessons of history. Each chapter of exploration has been marked by moments of uncertainty, yet also by remarkable breakthroughs born from perseverance and ingenuity. The challenges we face in our journey to the stars will undoubtedly mirror those of our ancestors, reminding us that humanity has always risen to meet the unknown with curiosity and courage. With each leap we take beyond our planet, we draw closer to understanding not only the universe but also ourselves. In this grand narrative of exploration, preparing for the unknown becomes a testament to our shared humanity. The cosmos invites us to dream and aspire, but it is our resilience that will carry us forward. By embracing uncertainty, cultivating our spirit, fostering collaboration, and remaining dedicated to ethical exploration, we pave the way for a future where the stars are not just distant points of light, but attainable destinations. As we embark on this journey, let us remember that the unknown is not a void to fear, but an open door to the incredible adventures that await us as we strive to weave our story into the fabric of the universe. As we gaze into the vast tapestry of space, it's essential to reflect on the legacy that space exploration has woven into the very identity of humanity. This journey has not only been about reaching distant celestial bodies but also about understanding our place in this incredible cosmos. History tells us that our quest for the stars began with mere curiosity, a spark ignited by the desire to comprehend the universe beyond our horizon. In ancient times, the night sky offered a canvas of wonder, filled with constellations that guided sailors and inspired myths. These celestial narratives shaped cultures, intertwined with the human experience, revealing our innate longing to explore. The monumental steps taken during the space age marked a pivotal moment in this legacy.
From the launch of Sputnik to the Apollo moon landings, each mission was a testament to our capacity for innovation and collaboration. These endeavors transcended borders, bringing nations together in a common goal. The images of Earth from space have transformed our perspective on our planet, highlighting its fragility and beauty, and igniting a global consciousness about the need to protect our home. As we ventured further, we learned not just about the mechanics of space travel, but also about ourselves, our resilience, our ingenuity, and our capacity for wonder. The legacies etched into the surface of the Moon and the rovers on Mars serve as monuments to human determination. The footprints left behind are more than mere imprints in the dust, they symbolize a collective dream, a vision of what we can achieve when we look to the skies. Each scientific discovery, from the existence of water on Mars to the haunting echoes of cosmic background radiation, has enriched our understanding of the universe. These revelations encourage us to ponder profound questions about life beyond Earth and the possibilities of existence elsewhere. The more we learn about the cosmos, the more we realize that we are part of a larger story, one that extends beyond our fleeting moments on this planet. As we stand on the precipice of a new era of exploration, we must also recognize the moral implications of our endeavors. The legacy of space exploration invites us to consider the responsibility that comes with our curiosity. Ethical dilemmas arise when we think about colonizing other worlds and the potential impact on any existing life forms. Each step forward in technology empowers us to reach further, but it also reinforces the need for thoughtful stewardship of the universe. Just as we seek new homes among the stars, we must remember our duty to preserve the beauty and diversity of spaces we have yet to explore. The advancements in technology that have fueled our journey to the stars are also a testament to our collective creativity and determination. The intricate dance of physics and engineering that has made space travel possible has spun off innovations that have transformed life on Earth. From improved telecommunications to advancements in materials science, the pursuit of knowledge in the cosmos has led to breakthroughs that reverberate throughout our daily lives. This legacy of innovation continues to inspire generations of scientists, engineers, and dreamers who look to the heavens for the next frontier of discovery. As we consider the future, we must acknowledge that the legacy of space exploration is not merely about the past, it is a living, breathing testament to what we can achieve together. The foundations laid by previous generations guide our approach as we embark on ambitious missions to explore the moons of Jupiter and the rings of Saturn. The technologies that emerge from these explorations will shape not only our journey into the cosmos but also the future of life on Earth. They will redefine what it means to be human in a universe filled with possibilities. We are at a crossroads, poised to turn our gaze outward into the deep abyss of space, and yet inward toward the lessons that our past endeavors have taught us. The stories we tell about our exploration of the stars will shape the narrative of humanity for generations to come. They will inform our understanding of cooperation, conflict, and the shared vision that drives us forward. Our legacy will be one of unity, where the differences that once divided us fade in the wake of a common purpose, the exploration of the universe in all its vastness and mystery. As we envision our future among the stars, we must foster a culture that embraces curiosity and courage. Let us inspire the next generation to dream big, to reach for the unattainable, and to never shy away from the unknown. The legacy of space exploration is a beacon of hope, guiding us toward a future where the stars are within our grasp. It is a reminder that we are all part of this cosmic journey, a shared adventure that transcends time and space. So let us celebrate the legacy we inherit, for it is not merely a history etched in the heavens, but a promise of what is yet to come. As we prepare for the next phase of our journey, let us carry forward this legacy with reverence, curiosity, and an unwavering commitment to explore. For in doing so, we not only honor those who came before us but also ignite the spark of exploration that will illuminate the path for those who follow. Together, we will continue to weave our story into the grand tapestry of the universe, pushing the boundaries of what is known and daring to discover what lies beyond. As we stand on the brink of an unprecedented era, it's vital to embrace the future with open minds and courageous hearts. The dream of thriving among the stars isn't merely a fantasy, it's becoming an achievable reality thanks to our relentless pursuit of innovation and discovery. Imagine a time when human life extends far beyond the cradle of Earth, where entire communities flourish on distant planets, united by a shared vision of exploration and understanding. This is not just an aspiration, it's a destiny that we are actively shaping.
The universe is vast and full of possibilities, and as we venture into this cosmic frontier, we must harness every tool at our disposal. The advent of quantum technologies, advanced robotics, and artificial intelligence isn't just enhancing our capabilities, it's redefining them. Picture a future where quantum computers analyze complex environments of alien worlds in real time, unlocking secrets of their atmospheres and potential for life. This kind of insight could revolutionize our approach to colonization, allowing us to adapt and thrive in conditions we have yet to fully comprehend. Moreover, as we push the envelope of space exploration, we must remember that the journey is as crucial as the destination. Each mission, each discovery, adds to our collective knowledge, connecting us not only with the cosmos but also with each other. The challenges we overcome together will forge new bonds and deepen our understanding of what it means to be human. In the grand expanse of the universe, we will learn that our differences are not barriers but strengths, enriching our experiences and perspectives as we venture into the unknown. Envision a society where technology and humanity harmonize, a balanced coexistence that enables us to thrive in environments beyond Earth. The concepts of terraforming and colonization promise not only the survival of human life but the flourishing of diverse ecosystems on planets we have yet to touch. Through careful stewardship, we can create new biospheres that mirror the beauty and complexity of our own planet, allowing humanity to become responsible caretakers of worlds yet unformed. Yet, with such incredible power comes profound responsibility. As we journey into this new age, ethical considerations must guide our actions. What does it mean to establish a presence on another world? How do we ensure that we do not repeat the mistakes of the past? These questions will shape our discourse and decisions, compelling us to act with integrity and foresight. Embracing the future demands that we prioritize respect for any existing ecosystems and potential life forms, cultivating a mindset of coexistence rather than conquest. As we reach for the stars, let us also acknowledge the critical role of international collaboration. The challenges of space exploration are formidable, but together we can surmount them. Nations across the globe are beginning to recognize that the cosmos is a shared frontier. By pooling our resources, knowledge, and creativity, we lay the foundation for a united effort that transcends borders, cultures, and ideologies. This collaborative spirit will not only enhance our chances of success but will also ensure that the benefits of space exploration are shared widely, inspiring generations to come. In this interconnected journey, we should not overlook the transformative power of virtual and augmented reality. These technologies hold the potential to bridge distances, allowing individuals to experience the wonders of space exploration from their homes. Imagine students donning VR headsets and taking virtual trips to Mars, or scientists collaborating on distant missions while feeling as if they are side by side. Such experiences can ignite curiosity and inspire a new wave of explorers, thinkers, and innovators eager to contribute to our collective journey. As we collectively prepare for the unknown, we must cultivate a spirit of resilience and adaptability. The cosmos is unpredictable, and our endeavors will inevitably yield unexpected challenges. Yet, it is through facing uncertainty that we grow stronger. With each setback, we learn, adapt, and innovate, driving the continuous evolution of our technologies and our understanding of the universe. Embracing the future means welcoming the unknown with optimism and creativity, confident in our ability to adapt and thrive. As we forge ahead into this new era, let us not forget the importance of storytelling. The narratives we weave about our explorations will serve as the backbone of our shared human experience. The legends we create about venturing to other worlds, the triumphs and trials we encounter, will inspire future generations to look to the stars and dream boldly. The legacy of our journey will not just be measured in the technologies we develop or the worlds we inhabit, but in the hearts and minds we ignite along the way. Embracing the future requires us to envision a world where humanity is not confined to a single planet but is a multiplanetary species. As we cultivate a deeper understanding of our place in the cosmos, we will embrace the vast potential that lies ahead. Together, we will not only explore the stars but also strive to understand our identity in the grand scheme of the universe. With each step we take, we'll weave a legacy that echoes through the ages, a legacy of exploration, unity, and discovery that inspires all of humanity to reach beyond the horizons of our imagination. As we stand on the precipice of a new era, the interconnectedness of quantum technologies and human aspirations paints a vivid tapestry of possibilities, each thread resonating with the promise of discovery. The universe, with its infinite mysteries, beckons us to embrace the unknown, inviting us to expand our horizons not just beyond our planet, but deep into the very fabric of space and time. Quantum mechanics, once confined to the realms of abstract theory and laboratory experiments, now emerges as a cornerstone of our ambition to explore the cosmos. From the unpredictable dance of particles to the elegant structure of quantum entanglement, these concepts are no longer mere scientific curiosities, they are the foundation upon which our cosmic journey will be built. Imagine a future where communication across vast distances in space becomes instantaneous, where messages are transmitted through entangled particles, enabling us to share knowledge and experiences with distant colonies on Mars or beyond as easily as we send a text today.
The implications are staggering.
Quantum computing will unlock vast amounts of data processing power, allowing us to simulate complex environments and predict the consequences of our actions as we terraform new worlds or design cutting-edge propulsion systems. This harmony between human ingenuity and quantum technology will catalyze a renaissance of space exploration, propelling us toward the stars with newfound confidence.
The very essence of our humanity is our insatiable curiosity, and as we gaze into the cosmos, we are inspired to ask the fundamental questions: what lies beyond our solar system? Are we alone in the universe?
With the power of quantum technologies, we are equipping ourselves with the tools needed to seek out answers to these profound queries. The search for extraterrestrial life is no longer a distant dream but a tangible mission, powered by advanced sensors and AI-driven algorithms that can sift through the vastness of the cosmos more efficiently than ever before. The deeper we venture, the more we understand not just the universe, but our place within it.
Yet, as we embark on this journey, it is essential to remember that exploration comes with responsibilities.
The ethical considerations surrounding space colonization become critical as we explore new worlds. We must tread lightly, preserving the integrity of these celestial bodies while nurturing our own planet. Our quest to colonize must be rooted in respect, cooperation, and a commitment to sustainability, ensuring that we leave behind a legacy of stewardship for generations to come. The unity of purpose will be our guiding light, illuminating the path for humanity as we navigate the challenges of the universe together.
Robotics and autonomous systems will amplify our capabilities, allowing us to explore inhospitable environments and conduct scientific research in ways previously unimaginable.
These technologies will act as our precursors, preparing the way for human footsteps on distant planets and moons. Imagine rovers equipped with the latest in AI and quantum computing venturing forth on terrains that challenge our very existence, gathering data that fuels our understanding and accelerates our progress.
The interplay of human insight and machine precision will be pivotal as we continue our celestial odyssey.
And then there is the role of biotechnology, a field on the brink of transforming our very biology to adapt us for life beyond Earth.
Genetic modifications could allow us to thrive in alien atmospheres, harnessing the capabilities we need to survive and flourish in environments vastly different from our own.
Coupled with virtual and augmented reality technologies, we can train for these conditions on Earth, immersing ourselves in simulated environments that prepare us not just physically but psychologically for the challenges ahead.
As we consider the concept of space elevators, we find a vision that could redefine how we access the cosmos.
Imagine a structure that reaches from the surface of our planet into the heavens, revolutionizing how we transport goods and people into space. This dream, once thought to be the stuff of science fiction, becomes increasingly feasible with the advancements we make today. Interstellar travel, once a concept relegated to the imagination, is slowly inching closer to reality through innovative propulsion techniques, charting paths that could one day take humanity to the stars. The cosmic internet will connect us all, knitting together our distant outposts and fostering collaboration across the galaxy. As we share knowledge and cultures, we will aspire to create a more united human experience, drawing strength from our diversity as we work together towards a common goal. International cooperation will be paramount, as the challenges of space exploration require a global response. Only through collaboration can we hope to realize our dreams of becoming an interstellar species. In concluding this journey through the cosmos and the technologies that will propel us there, we find ourselves not at an end, but at a beginning. The legacy of space exploration will not only shape our understanding of the universe but will redefine what it means to be human. As we embrace the future, we will carry with us the hopes, dreams, and collective wisdom of our species. Together, we will reach for the stars, driven by an unyielding spirit of discovery and the quest for knowledge. From our humble beginnings on Earth, we are destined to carve our place in the cosmos, forever inspired by the infinite potential that awaits us. The stars are not merely points of light in the night sky, they are destinations, each one a promise of a new adventure, a new chapter in the story of humanity.